Moving forward, we are having our fourth session where we have the privilege of learning from Mr. Saibal Saha, a distinguished professional with more than 30 years of expertise in architectural engineering, urban sustainability, and environmental management. Mr. Saha earned his BE in civil engineering from Jadavpur University and further specialized with a postgraduate diploma in urban environment management and law from National Law University, Delhi. Over the years, he has acquired several prestigious professional accreditations, including Chartered Engineer, Professional Engineer, Certified Energy Auditor. He is also a fellow and accredited professional of the Indian Green Building Council, a certified trainer, and a master trainer for India's Energy Conservation Building Code. His outstanding contribution have been recognized nationally and internationally. In 2019, he was awarded the title of Energy Engineer of the Year by the Association of Energy Engineers USA. Beyond his credentials, Mr. Saha has served in multiple roles as an environmental coordinator, water auditor, sectoral expert under the BE-PAT scheme, and the project management professional. Today, he will enlighten us on the very relevant topic of urban design in the light of national and international policies, drawing from his vast experience in green buildings, energy efficiency, and sustainable and urban development. So, let us warmly welcome Mr. Saibal Saha to deliver his expert lecture.
Good morning, everybody.
Good evening, sir.
I just want to start the session. Just let me mute it. So it was here. I have to check where it is. Is it can you see the screen?
Yes, sir.
Yes, sir. We can see.
Yes.
Yes, sir, we see it.
So today my topic is development of means just a minute. I want to minimize the screen. Where it is. Just development of urban design in the light of national and international policies for climate change mitigation. So just a minute, just a minute. But it is not. Okay. So we are facing climate change in our everyday life. And not only it is geographically bound to any country, the catastrophe and effect of climate change is being observed everywhere. We have already observed 1.2 degrees centigrade rise in temperature and trying to contain it by 1.5 degrees centigrade as per the international forum. So this is the last 9 years was warmest on record. Global temperature anomaly from 1951 to 80 have observed as per the what I'm showing in the slide. It is rising drastically. So what are the causes of climate change? Particularly, it is increase in GHG emission and not means and the consequences causes burning of fossil fuels, deforestation, industrial practices, and we have the consequences extreme weather events, environmental changes, and severe heat and cold waves. So these are the hazards. We have the data from different sources. The impact of climate change being felt in both inhabited land and oceans. There are sea surface temperature rise, what being measured, but the land surface temperature is now also a cause of concern. So average warming of 1.5 degrees centigrade across the whole globe raises the risk of heat waves and heavy rainfall. What we have seen already in every year in different parts of our country as well as internationally. So based on pathways identified by IPCC, two modeled scenario with temperature rises from 1.5 degrees centigrade and 2 degrees centigrade are presented pictorially here. Exposure to risk, IPCC emphasizes multi-sector risk assessment as a critical tool for understanding the wide-reaching impacts of global warming and climate change. The heat map presented here is a multi-sector risk map for a 1.5 degree centigrade temperature rise with score ranging from 0 to 9. And locations having a score above 4 are considered to have multi-sectoral risk due to global warming. India is hardly hit as per the picture or map shown above. So it is significantly impacted. Now, the assessment of climate change over the Indian region published by Indian Ministry of Earth Science in 2020 is that average temperature rise has risen by around 0.7 degrees centigrade from 1901 to 2018. Frequency of daily precipitation extremes, rainfall intensities greater than 150 millimeter per day increased by about 75% during 1950 to 2015. The frequency and spatial extent of droughts over India has increased significantly. Sea level rise in the North Indian Ocean occurred at a rate of 3.3 millimeter per year in the last 2.5 decades. And frequency of severe cyclonic storms over the Arabian Sea has increased during the post-monsoon seasons during 1998 to 2018. And another thing, the right side graph is actually cooling degree day. Cooling degree day is an industrial term, and it is actually the number of hours which is beyond a certain temperature we feel comfortable. In USA or Europe, CDD 18 degree is generally is the term. Means CDD 18 means above 18 degrees centigrade, how many hours of a year are there. So in India, we have our comfort temperature raised to 24 degrees centigrade. If 24 degrees centigrade is benchmark, then also our cooling degree days have reached a several notch above the what we have faced in 80s or 70s. So that is a clear observation that the warming is there, and that is those have to be managed anyhow to contain these heavy rainfall, flooding, or heat waves, particularly in the urban areas. So urban design should be planned or made in such a way that these temperature rise or heat island effect could be maintained to a certain extent. It is another Southeast Asia increasing cooling demand. And the cooling demand, everyone feels that Indian cities now require more air conditioners than what we have seen earlier days. In earlier days, very little of the city homes had air conditioners. Now, almost every home in urban India, though it is still 7% penetration of personal air conditioner in our country, but most of the houses have at least one air conditioners in their homes. That is because of that overall urban temperature rise as well as heat island effect due to rapid urbanization, unplanned urbanization. We'd be coming to that extent how our urban design should be made so that these could be minimized, means our comfort parameters could be obtained without having a air conditioners for a large period of the year. Without air conditioners may not be an option because comfort, the parameter earlier which was thought of a just luxury, today it is thought as a necessity. So the perception has been changed, but still the requirement of having air conditioners running within our homes could be minimized if we could adopt a good urban design. So potential disasters, it is just a 5-country analysis. The data is like that, particularly in the Asian countries, that Cambodia, India, Indonesia, Thailand, Vietnam, the flood risk in India, it is 9.2, whereas the hazard is above 7. So coastal flood, India 7.8, drought is lower, but tropical cyclone is highest among the countries. So India, particularly, we have many disaster risk means due to climate change. So our country face the vulnerability most due to these climate change. We have to be proactive. At least I don't know whether we are already short of time, but we are still trying to contain the urban design in such a way that this could be minimized. Now, coming to the energy scenario. Why I'm coming to the energy scenario? Because GHG, coming directly to that GHG is principally coming from energy usage. So let us look at the energy scenario of the Asian region and India. That Southeast Asia accounts for 9% of the world population, 6% of the world's GDP, and 4% of the world energy consumption. The energy demand in Asian region is expected to triple by 2050 from 2020 level. So our population, we are already the most populated country in the world, and it is expected to grow till 2050 exponentially. And our energy demand would also be increased due to that population rise and rapid urbanization, as well as the perception of comfort level is getting changed. So potential growth areas in Asian member states are infrastructure, high-tech manufacturing, electric vehicle, energy demand for growing middle class. So our middle class is growing, urban population is growing, so energy demand is also growing. And that also fuels the GHG, more GHG emission in the atmosphere. So per capita, it is a study by 2050. Total CO2 related emissions from Asians is expected to double from 2022 level, mainly from the transport, power and industrial sector. Urbanization and motorization are significant drivers to the per capita energy demand. Per capita total final electricity consumption to increase by 35% by 2030 and 210% by 2050 in planned energy scenario. So if we could plan also, then also these energy would be increased, energy demand would be increased. But without unplanned, it could be much more. So with the right policy and finance levers, 75% reduction could be achieved. Energy emissions, India is the 5th largest, now it is 4th largest already. March 2022.
ఎప్పుడు నా ప్రాణం
India's population surpassed China in 2022. India will peak at 1.7 billion people by early 2060 and will remain as the world's most populated country in the 21st century. Historically, the rise of GDP has resulted in the rise of energy consumption per capita.
బర్త్డే రోజు బ్లెస్ చేయాలా ఎప్పుడైనా బ్లెస్ చేయాలి ఏమయ్యారు పుట్టినరోజునే బ్లెస్ చేయాలా
India's energy demand will double by 2050 and is heavily dependent on fossil fuel consumption. Our energy basket is still above 60%, though our renewable energy reached a milestone of 50% of the total energy consumption, but that is the capacity. But the usage is still more than 60%. As the fossil fuel, particularly coal burning.
సౌండ్ ఇక్కడేనా
So that is a relation of energy usage and GHG emission. So if we contain the energy usage, overall carbon dioxide emission would be reduced. We'll be coming to the carbon dioxide part and GHG part. Carbon dioxide is not the only culprit. Energy and carbon emission, globally building consumes more than 30 to 34% of total energy demand for operational requirements and production of construction materials. So there is a significant percentage of energy what we generating and putting into the grid is being consumed by the building sector, by its operation, means our daily usage, as well as the manufacturing of the construction materials. So if we could reduce these energy usage by good design measures, then these energy consumption would be reduced, that could be reduced up to 50%. And 50% of 30%, that also making it a 15% of the overall energy consumption by changing the design only as well as material usage. So it is a very low hanging fruit for the Indian policymakers to implement the energy code as well as the practice of building design and the use of materials. So let us come to that. But overall, CO2 emissions from buildings, operations and construction reached a new high of 37% in 2022. It is going to be more because the more the population increases, the more the demand for buildings, and the more would be our building energy consumption. So overall, in economy, these demand for energy, particularly or carbon dioxide emissions from building sectors would increase. Now, we are talking about CO2. Just one question. You can just comment on the box that is CO2 is a good thing or a bad thing for our environment. You can write in the chat box. And I think we have to discuss it elaborately to understand what CO2 does. The hottest planet. Our average temperature, we have enough carbon dioxide to make our planet livable. So if our planet doesn't have CO2 or that cover to contain the GHG, then what would be the scenario? Earth's average temperature would be minus 18 degrees centigrade. So CO2 or GHG is necessary, but of making the off balance, making it off balance, creating the problems what we face today, and the discussion what we are making now is about that. It is the thing that there is a debate still that whether it is natural, this CO2 increase of GHG, or it is human induced. But the overall research for last centuries also, and the data we have, it is found that human-induced warming actually the culprit, because we have used fossil fuel exponentially. Our after industrial means revolution in Europe, and since then the use of fossil fuel make it the global means CO2 level or overall GHG level in our atmosphere, making the this catastrophe. We have seen that July 5 have already unofficially recorded as the hottest day on Earth. We have seen in our cities, today at Kolkata, it is around 34 degrees centigrade, the maximum temperature. Minimum is around 29. Still, in this year, we haven't felt the heat wave that much because incessant rains and almost regular rains were there. That causes flooding in some other parts of the country. But this year, the temperature rise was not so high. In Kolkata also, we have failed above 40 degrees centigrade even last year or last year. So this is a natural thing, new normal for most of the Indian cities. Whereas earlier, decades ago or a couple of decades ago, 34-35 degrees centigrade was the normal maximum temperature. So that is the thing. And not only CO2, the GHG consists of some other gases also, that CO2, CH4, N2O, methane, nitrous oxide, perfluorocarbon, hydrofluorocarbon, sulfur hexafluoride. So these are GHG gases, and when we are doing life cycle assessment, we are considering all these gases to have the GHG pattern, means the total emissions. And I think many of you know that Government of India has recently launched Indian carbon market, in which carbon credits will be traded within the Indian business community, and the willing means uh, uh, any institution or any organization who are willing to participate in the Indian carbon market, they have to register in the market, and they have to show that they have this much of emission reduction to have some credits, and those are tradable. So all these things, but now at this level, I think CO2 and PFCs are included only for the industries, but gradually all other gases would also be included in our carbon market trading schemes. So ability of gases to absorb um, uh, um, heat is these, that CO2, if we take CO2 as a unit 1, then methane has some 25 to 27 as per the assessment report. Nitrous, methane fossil, non-fossil and fossil, there are two values, and nitrous oxide, it has 298 times of carbon dioxide. So it is much more harmful, as well as the lifetime of the gases. Sorry, lifetime of the gases. So carbon dioxide variable, well, while nitrous oxide is 121 years as their lifetime. So it is more potent to have these GHG effect in our atmosphere than the CO2. So these are the values. We understand these things, that how the global warming through GHG and through various gases of GHG causing gases are we have the data of these gases. So I want to make it clear that how the global warming is being happened. So with the GHG and the potential of different gases. Now, regarding commitments and national, international, different, not only commitment, these are the framework for the containing these carbon dioxide emission or carbon emission. So there are pledges, commitments, there are the conference of parties. So we are coming to that mitigation measures, that 153 countries have net zero targets in NDC, nationally declared carbon emission reduction. So 153 countries have their net zero targets, and urgent strengthening of targets and accelerated actions on coal deforestation, methane, and electric vehicles. These are the International Energy Agency 2022 data. Adaptation, boosted efforts to deal with climate impacts and support vulnerable countries to adapt, minimize loss and damage, mobilize public sector finance in US dollar millions and private sector finance in US trillions. Over 40 countries endorsed the breakthrough agenda. Global pledges, we have Conference of Parties, United Nations Framework Convention on Climate Change, UNFCCC. The COP is the main decision-making body of the UNFCCC. COP28 was held in the UAE in December 2023. And these are the different framework when the pledges have been made. COP3, Kyoto Protocol. Many of us know that
Okay.
37 industrial countries and EU committed to reduce their emission by 5% from 1990 level. And through that Kyoto Protocol, that carbon credits or CDM project of United Nations have developed. So through that Kyoto Protocol, the developed countries through their because of their historic emissions patterns, they pledged to buy the credits from different countries, from their countries also, as well as from developing countries to have their commitment of their 5% reduction. COP26 Global Methane Pledge and collectively reduce anthropogenic methane emissions by 30% from 2020 to level by 2030. COP28 set goal to triple the share of renewables in energy supply and double the annual rate of increase in energy efficiency from 2% to 4% by 2030. And COP28 Global Cooling Pledge, endorsed by 71 countries, collective global targets to reduce cooling-related emissions by 68% by 2050. These increase significant access to sustainable cooling by 2030 and increase global average efficiency of new air conditioners by 50%. Many of us know that CFC has already been banned, and you cannot find CFC refrigerant in most of our gadgets, air conditioners, refrigerators, firefighting equipments nowadays. But CFC, what I replace CFC initially with HCFC, hydrochlorofluorocarbon, but that also contain an atom or molecules of fluorocarbon, hydrofluorocarbon. That also has some your ozone depletion potential as well as global warming potential. So we have transformed, means industry has transformed from HCFC to HFC, hydrofluorocarbon, which has zero ozone depletion potential, but to some extent for different HFCs, different global warming potential. But we are now targeting that these hydrofluorocarbon almost going to be banned in a few years, so that we would be using a different kind of refrigerant. It could be nitrogen, it could be some anything. We don't know yet what would be the refrigerant, what would be the cooling pattern, what would be our comfort level to achieve what would be the technology to give us the comfort level what we require for particularly for different countries. Different countries have different level of comfort. All the countries don't have the same level of comfort. So we are yet to finalize, and every year there are competition challenges throughout the world to have these different refrigeration system as well as different cooling technology, so that these HFC, hydrofluorocarbon, or hydrocarbon specifically, hydrochlorofluorocarbon, that could be banned, and a new refrigerant, new type of cooling to give us comfort level to achieve that target. So particularly India, when India is a cooling dominated country, our cooling degree day is much higher, even our neighboring Asian countries. So we need to adopt cooling, particularly India, Bangladesh, Pakistan, Afghanistan. These areas have high cooling requirement. We need to have these cooling strategies to to work with so that that has minimum global warming potential also. So, Stocktake from COP28, recognition of science that indicates GHG emissions need to be cut by 43% by 2030 compared to 2019 level to limit global warming to 1.5. COP28 presidency sets 4 pillars for the summit. Fast tracking a just, orderly, equitable energy transition, fixing climate finance, focusing on people lives and livelihoods, underpinning everything with full inclusivity. I mean, everyone should be included from different parts of the society. So that is the target. Otherwise, the entire pledges all our efforts to reach there would be futile. Now, COP Paris Agreement 2015, that is a path-breaking COP21, we generally refer, signed by 195 countries and ratified by 190 countries. USA have recently gone out again, but earlier they have ratified it, holding the increase in global average temperature to well below 2 degrees centigrade above pre-industrial level. Pursuing efforts to limit temperature increase to 1.5 degrees centigrade, and NDC's nationally declared commitment from nations to United Nations to reduce their GHG emissions to mitigate climate change. I have just mentioned that carbon market, Indian carbon market, and you may know that India have their energy conservation Act in 2001, which has recently been revised in 2022, in which these entire system of carbon market has been included, and how the trading would be done, everything is given there. And from in that 2001 Energy Conservation Act, there was provision for conserving energy in industry or through designated consumer. Designated consumers were those consumers which consumes energy more than 10,000 cubic meter metric ton of oil equivalent, 10,000 metric ton of oil equivalent. So after that, that was in the Act of 2001, but in 2022, it has been revised to include many other things. There was some building codes, particularly for what I have told, that building causes or consumes 34% energy, and it is going to be increased very soon, much more than 34. So our target to reduce energy consumption through buildings and through means through urbanizations. So that is the thing. India's NDCs, particularly, there are the 5 countries, updated in NDC 2021, Panchamrit, increased non-fossil fuel energy capacity of 500 gigawatt by 2030. But I want to share with you that by 2025, we have already reached these 500 gigawatt target. Meet 50% energy requirement from renewable energy that I am just told by 2030, and reduce total projected carbon emissions by 1 billion tons by 2030. We are yet to reach there. Reduce carbon intensity of the economy to less than 45% by 2030 from 2005 level, and achieve net zero emissions by 2070. It is a big thing. So net zero, these net zero economy is a big thing, and Government of India is very serious about that to achieve these net zero target by 2070. Now, particularly building related NDCs are energy and material efficiency in buildings and increased climate resilience of cities, smart city initiatives, integrated planning of cities for mainstreaming adaptation and enhancing energy and resource efficiency, effective green building codes, and rapid developments in innovative solid and liquid waste management. So these are India's NDCs. We have already have our building code. In 2007, Energy Conservation Building Code has been enacted in India. And after that, many things happened. In 2017, it has been revised like any other codes, which is supposed to be revised within 10 years, means at least in 10 years. So, and particularly when energy is means energy is the topic, India trying to get it done very rapidly. I think you heard the debate about these ethanol blending. You are well concerned about buying of Russian oil, and all are due to these energy security. India mostly dependent on foreign countries for petroleum or these kinds of fuels. So we are trying to be energy secure, energy sufficient by several measures. One measure is ethanol blending. One measure is getting cheap oil from a foreign country. Another is definitely to minimize urban energy consumption. It could be transport, it could be our municipal sector, which is providing street lights, providing pumping, having their solid waste management systems, having their road means and other things, construction material, manufacturing sectors. So reinforcements, all these actually creating means these producing GHG gases. So we are trying, India government is trying to mitigate. To mitigate means to minimize these consumption, not only for climate, but also for our country's means energy security. So it is a two-fold approach, means two-way approach to have Atmano Mokshartham as well as Jagat Hitaya. We are trying to be self-sufficient as well as trying to make good for our Mother Earth. Now, coming to the tools for planning and design of low carbon buildings. So I am just coming to that part, that how we can minimize our requirement for building construction, as well as not here. I would be trying to make it for the design as well as operational energy. To some extent, very little, though, that embodied energy that in our building materials, we are trying to mitigate energy consumption through using local materials, through using recyclable materials as much as possible, to measure it by life cycle assessment, to certify it through by environment product declarations by a third party, by certifying our building material products, what CII have, a Green Pro rating system, Griha Council have their own certification system of building materials. So the process is there, but still it is in the formation stage. Just last 5 years ago, CII have developed this Green Pro rating system. Green Pro rating system is the materials which are green products. And within 5 years, initially it has started with just means hundreds of products, maybe may not be hundreds, some tens of products. Some Today it is more than 11,000 building products which are getting certified. So and we, the green building professionals, are using these buildings for getting a good rating system for our buildings which are getting pre-certified from Indian Green Building Council, Griha Council, or ASSOCHAM, which are the Indian standards we are dealing with in India. So I would be those are not covered in these means slides, but these are the things. You may ask me any question. I would be happy to answer those. So just operational, I want to tell you how to minimize operational energy consumption through design. The first is integrated design process. Integrated design process, if we are design very early in the design stage, then it would be actually a very good energy conservation measure. Let's see how it is. That conventional design process, that lack of integrated view of the project, generally what we do, the client hired an architect, and he has creating a schematic design. He has when the design development phase comes, then structural engineer is included, then HVAC engineer. We call them MEP designer or service designer, MEP designer, HVAC engineer, green building energy consultant. Those are included at the design development phase, and these are going on. Then during construction drawings, then project, when the construction drawings are being prepared and the work is going to start, at that time construct project manager and contractor would be coming into the picture. These are the sequential process where different specialist design consultants and stakeholders are brought in separately after much of the architectural design has been fixed to give their respective technical inputs. It is still now when we are getting our orders or commissions of green building projects, we are getting the architectural plan from the architect or the builder or the owner, and then there was no one, not even the MEP consultant, not even any PhD consultant. No contractor, no question of contractor. There is a very early stage when I am asking the owner or builder, he generally tells that it is very early to consider an MEP consultant, let alone the contractor or construction manager. So this is the process. Now, integrated design process, when to have an integrated design chart, then integrated design means most of the stakeholders, if not all, start working on the project together right from the beginning. If at the very beginning, a project management team would come into into existence. So project management team who contacts and along with the architect, there would be a project management team. There could be, or at least a small team of 1 or 2 persons. Then a MEP consultant, maybe definitely with an energy analyst. Then the best and most effective time to have the first share it is the conceptual stage of the design. When the OPR means owner project requirement is being developed, what he wants to do with the building, how it would be scheduled, what would be the type of people, where it is located, means whether it would be used in such a way that during morning it would be school, but at night time it would be a convention area or some assembling area or a library, or in the same property there would be some Means it is a shared basis. If that is the thing, then you have to think of in a different way. So it is the very early stage when a project management as well as an energy analyst would be there. Maybe a commissioning agent would also be there. The commissioning agent actually, this term is very new. Even in Eastern India, we generally are fumbling with getting a commissioning agent. We don't have a commissioning agent here. We generally hire commissioning agents from southern states or western states. Here, the commissioning agent, we generally knows the energy auditors, certified energy auditors from Bureau of Energy Efficiency as per GRIHA or as well as IGBC. But the energy auditors and commissioning agent, there is a slight difference. The commissioning agent would be there at the very inception, and he would be preparing the owner's project requirement. And owner's project requirement would be getting designed by the architect as well as by the MEP consultant. That would be analyzed by the energy consultant. And commissioning agent would take part in the design of the architect, design of the MEP, design of the energy consultant, means energy or energy analyst. So that is the time when you can have all them together. You may not have the contractor at that stage, but at least these 3-4 agencies, that could be a single person, that could be a company, but these agencies should be on board at that stage, at the very design inception stage, when the schematic design is being developed. So the slide tells you about that. And this is the thing, that when you business as usual, your energy consumption, it is a proven fact. Many of the buildings in India, in Chennai, in Mumbai, in Bangalore, it has been, when operated for last 4-5 years, the data shows that when the design is done as business as usual, and when these people, like a commissioning agent, MEP consultant, and energy analyst, comes in being from the very beginning, it goes to 30 to 40% less. So that is the idea of including a commissioning agent at the very beginning of a design process, at the initiation of a new project. It is a simple tool. You may hire a person which would be hired some months later. You could hire early, and maybe the fees are limited to the total project cost. So if they are coming late, they would be charging the same cost, but giving you services much lesser than what it should be. So the aim should be to get a climate responsive design first. I am talking about climate, but it is actually, I am talking about rupee, the money. I am talking about the lesser energy consumption. I am talking about lesser carbon dioxide oxide emission, and then the lesser climate means climate mitigation would be higher. The SHAREit is a tool to implement an integrated design process. It is nothing. You need not to have any other thing. It isn't just idea, the process, the system. We have to adopt in our urban design process to get it done. It has a potential to conserve 30 to 40% of your annual energy consumption. Now, what do you integrate? The concept stage, set goals. What I have told, that OPR, comfort and DPI. I would be coming all these parameters. The comfort. Now, I have told about the comfort. What we actually need is comfort in a building. The purpose of building is actually to give you comfort. What comfort? Thermal comfort, visual comfort, your acoustic comfort, So in a market, you don't have acoustic comfort, but within your room, when I am talking with you, I have a very good acoustic comfort. It is serene, still, no horns, no honking, no barking, nothing is here. So acoustic comfort is also very much requirement. So comfort and EPI, EPS energy performance index. I'll be coming all point by point, and CO2 intensity. Do you need to build new? Can you reuse recycle material of existing building? When you are going to a plot, your owner or a builder is getting a plot which have some existing building. So those definitely would be demolished. But could you use those material in your new building? Or some part of the building to be converted? Many of our green building projects, we are doing that. Some part, it is a desolate building or 100-year-old building or abandoned building due to some litigation. Now a builder has come to terms with all the landowners, etc., to get it done, get it erected. And then the earlier developer or agency which have constructed a part of it completely different from the new proposal, that is getting integrated in the new proposal. So that is the thing, that without demolishing that part, you could integrate in your design. It could be in your foliage, it could be in your same as for the plants, trees and plants. If you can manage not to cut the plants, then it is better. That reduce your heat island effect. And we are always trying to have that have some credit points in green building rating system. So schematics, after concept stage, we are coming to schematic design, shape massing option, how the building architects would know it very more than me, that how the massing, shaping would be done. Then structural system comes. Then envelope system. Envelope means the walls, means opaque part, the fenestration part, the glazing part, then roofing part, the flooring part. This comes the type of HVAC system. Here again, the HVAC system. Sometimes which system gives you the most efficiency, you need to think at that stage. Whether it is chiller, whether it is VRF system, whether it is vapor absorption refrigeration. If you have some hot water or some steam which is getting wasted, if you could get it used through vapor absorption refrigeration process, then definitely that would reduce your energy bills to at least 50%. Because you are using waste heat to your refrigeration or HVAC system. So these types of things you need to choose or need to finalize a schematic design phase. Then design development, reduction in cement and steel, how it could be done. So many even now in LEED, US Green Building Council, they have they are building some credit points, 2-3 credit points for LCA study. You have to have LCA, that is a mandate also, LCA, life cycle assessment of the building. There are several tools doing LCA. I think you have some LCA classes also during these 6 days training program. So there are several tools, and the tools gives you when you are designing your building, for when you are modeling architectural through BEAM or not through Revit or something, you would be getting your total LCA, total carbon assessment. Just by simple clicking. The software is costly, but it is there already in the market and hugely used in several parts of the country. So you have to have reduce the cement. If you can reduce the cement, you have a boon in reducing carbon dioxide from the overall embodied carbon of your building. Similarly, steel, which are high energy consuming building materials. Then envelope hotspot. which envelope have higher hotspot in your LCA. Hotspot is a term very known in LCA studies. In industry, every industry are now doing, most of the industries, not every industries, most of the industries are now doing LCA, just not for climate, but to find the hotspot to minimize their product cost. So the envelope hotspot, internal layout, avoid elements with limited value, develop specification including bid documents, and in bid documents you need to do which person would be responsible of what, and then construction stage, conform optimization, reduce material waste and recycle it. During construction also, definitely many of you are from architectural, civil engineering, other engineering backgrounds. So there are a good percentage of good amount of steel rebars in being wasted and goes to recyclers or through Kabariwala. Those could be reused in your site for little important structure like boundary wall, like ramp, like roads, like chhajas, lintels. So if you could plan, if you have a proper bar bending schedule, you can do these things. Without planning, actually, you cannot. So integrated design chariot have mostly commercial building. The setting goals are here. Commercial buildings, mostly air conditioning, narrow band of expected comfort. Expected comfort, I'd be coming to that point. The mechanical engineers, definitely they know psychrometric chart and in the psychrometric chart, the areas where we are telling that this is the expected comfort band. So some degrees of temperature and relative humidity. Just psychrometric chart covers that. So we have that. Apart from that, some other factors also there. But mostly air condition, narrow band of expected comfort, air conditioning used in longer duration, maybe used throughout the year, heat loads in the building, because why throughout the year? Because mostly have closed boxes. It doesn't have the natural ventilation system. Most of the offices are commercial buildings are. So in winter also they need to have, due to ventilation, means to have the ventilation, to need to have the air conditions running. So the shared goals, a reduction in energy performance index. Energy performance index is an index. It is in kilowatt hour, means unit of electricity consumption or energy consumption per square meter of the building, excluding the parking, basement, mean not used by human beings. So per square meter of the building per annum, that is called EPI. So the lesser EPI, the more the better the performance. So cooling EPI particularly, because we require cooling. Most of the energies are being required for cooling. Additional parameters evaluated for specific problem identification or problem solving, heat gain from different building components, HVAC system sizing and efficiency, daylight free cooling potential. If you have some areas like temperate climate zones, some areas like Delhi are your composite climate zones. In the winter, you don't require cooling. So you require heating. So at that time, or a certain temperature region in the year where you could just filter the air and get it coming within your building. So that is adopted in the building code, that is already taken into consideration. But that is there. So free cooling potential is also there, and we are doing that. in water as well as air, which is required for cooling. And for residential building, may or may not be air conditioned, broader band of expected comfort. We generally trying to adopt as well as adapt with the external thermal or atmospheric condition. Air conditioning intermittent during the day and used mainly in the summer. Heat loads in the building dominated by external loads, that is those from the building envelope. Because in residential building, per square feet area to building envelope is much lower than the commercial building, or envelope to floor area is much higher in residential building than commercial building. Then the goals should be like that: reduction in peak summer internal operative temperature in comparison to base design, minimizing the discomfort degree day or degree hour. Though we have talked about comfort degree day, now discomfort degree hour is another term or index we generally use to have the residential building design. In summer, when assessed as per IMAC, IMAC is an Indian code, and it is a comfort band actually. The comfort condition. So additional parameters evaluated for specific problem identification or problem solving. We have RETV, resident envelope transmission value, a new index or coefficient is created to measure the envelope performance. And there are formulas, mathematical formulas, very simple, just arithmetic formulas, but you need to know the functionalities of the building. So if you have the functionalities of the building, then you can easily have the RETV value manually itself. You need not to have a tool. So but through Excel, you can have RETV. Cooling energy if the assessed space is air conditioned and natural ventilation potential. Strategies and analysis tool. Have the to reduce operational energy, weather data, climate analysis tool, sunpath solar radiation analysis, thermal comfort energy simulation tool, and all these are there. I would be coming in detail. And daylight simulation tool, natural ventilation potential. So now designer's role, elements to be addressed. An architect's primary function is to create an environment. That environment which gives you comfort. The environment is both physical as physiological as psychological. Physiological gives you comfort, your thermal comfort, visual comfort, acoustic comfort, air quality. And the psychological comfort, the aesthetics, your connectivity with exterior, that gives you the psychological comfort. In a jail, you may have all the things, the air conditioned and all the things, but it may not have psychological comfort because you are in a close, don't have it. And the environment impacts human productivity definitely. Because these human productivity, because of these things, we Indians are now feel that comfort is should be taken into consideration for our design. Everywhere in our transport system, in our in our homes, in our offices, everywhere we are thinking of these comfort parameters: visual comfort, thermal comfort. Now, site location, geometry, and the arrangement of space, local climatic characteristics. Now, simulation for whole building access, it is actually a specialized subject, and you need to have these things. You may start tools. Some are to pay a hefty price, but any kind of design, be it an auditorium, be it a guest house, be it a hospital, hotel, you can do, say, analysis through the free softwares. The performance simulation, approximate imitation of the operation of a process or system that represent operation over time. Computer simulation is a model, a real life or hypothetical situation on a computer so that it can be virtually studied. And building performance simulation, the replication of aspects of building performance using a computer-based mathematical model created on the basis of fundamental physical principles and sound engineering practice. The objective of building performance simulation is the quantification of aspects of building performance that are relevant to design, construction, operation, and control of building. Actually, when we are doing energy simulation, there are three types of simulation. I will be coming, I may be already late, but three types of simulation. Generally, for designing a building, we are helping the architects to have the most efficient comfort as well as thermally comfort, visually comfort, as well as most energy efficient buildings. We can present, the energy analysts can do at the time of schematic design itself. Building performance simulation, and that is energy, somewhere it daylight and somewhere it is the airspeed. The estimate energy performance, energy consumption by different end users, lighting, air conditioning, to estimate the thermal comfort inside the building, to understand the impact of climate on energy performance, to identify key areas that has more potential, to quantify energy savings, improvement in thermal comfort through different energy conservation measures, ECMs, helping in design decision making during schematic design. To save time, manual calculation is complex and require more time. Simulation software, these are the list of software packages. The Energy Plus, mostly used, and mostly used design builder in our country. And the free software, DOE 2.2 and based, which are eQuest. You can search eQuest. It is free. Visual DOE also free, but eQuest is most easy. Means apart from all other things, but still it requires a high learning curve. I cannot speak a false thing. So you need to be very patient for learning that. And these are the other softwares. Selecting a software, you must be a validated, approved software. Modeling capability, it has to model HVAC system, advanced component. If you need to install something which doesn't have the capability to include into their design parameters, then that software cannot be taken into consideration. It must have natural ventilation, adiabatic evaporating cooling, parametric analysis, means every parameter should be analyzed, and possibility to add specific capability, means which are yet to known, that also to be, when it will be known, that also at that time to be included in the software. That part should be there within the software. In this context, I just like to inform you, there is a laboratory at SEPT University, Ahmedabad. There they have a testing laboratory for upcoming HVAC system. That HVAC system that is yet to be built. For that, the performance parameters of that HVAC system, they have created a laboratory. So your software and all these softwares have these facilities. When design aspect which are yet to be thought is coming into the market or invented, the provision should be there to include that. Early design stage, simulate a small portion of the building in detail, specific parts or features of the building, what to check feasibility of different options, extreme conditions, focus on extreme conditions to check feasibility. We generally tell that as a box-like design. We need not to have entire rooms, the conditioned area, unconditioned area, all the glazing and dimensions, but we need to overall have some ideas that we need to have window wall ratio that much. We need not to go beyond that. If that is the scenario, then what is to be? Now coming to inputs and outputs, the weather data, dry bulb temperature, relative humidity, wind speed, ground temperature, those are included in your design. has to be, you need to put those values. Building geometry construction, when you are doing these designs simulation, you are going to just uh, um, import your CAD model. If it is not a BIM model, your CAD model into the design, and then create your model in that software environment. There are interoperability also. So when you are doing a BIM model, that is, or Revit model, that could be easily integrated in many of those design softwares, when simulation softwares. Then cooling, ventilation system, naturally air conditioned, internal loads, occupancy, lighting, equipment, even your ethnicity, your clothing. Many of the IT parks, IT sectors, IT buildings are now have their clothing, means dress code as informal. Because if in your informal clothes, you need to have lower air conditioning, lower higher temperature you could adapt. So your energy consumption through HVAC system would be much lower. If it is a huge park, then the cost could be some crores of rupees annually. And what is the output? Heat balance, heat gain through different building envelope, comfort results, system size, energy consumption for different uses, the annual energy consumption as well as index. Then essential skills, these are the knowledge and understanding building physics, air conditioning, good technical sense, and need patience. The last word is you need patience. You need to have the patience to iterate multiple times to reach your required result. So I am just coming rapidly to the am I audible?
Yes, sir,
Hello.
you
Yes,
are
sir, you
audible.
are audible.
Audible, sir, you are audible.
Now, coming to the daylight
Yes, sir.
simulation tools for visual comfort, and it is not only giving you visual comfort. For visual comfort in many office buildings, we generally have lights on throughout the day. If it is an 8 hours building, it could be a 24 hours building. Many of the office buildings have full day lighting on. Even in my office also, because of to restrict the glare within my room, I need to have the curtain raised and the lights are on. But if you have that kind of double glazing system, I don't have that. So if you have that kind of double glazing system or that kind of glazing system, you can have daylight coming into your desk without having lighting, means artificial lights. So daylight simulation, actually we require to have to understand how the daylight potential is within the building, how to reduce the lighting consumption within your artificial lighting consumption, and vis-a-vis the energy requirement in your building. So the simulation, understanding objectives are processes that help determine amount and quality of natural light. It affects occupants and energy consumption, involves simulating light behavior, physical model or digital tool to predict light distribution. Buildings from form interacts with light availability, different times of the day and seasons. It can help reduce the need for artificial lights, which can lower energy costs and emissions. These processes are often used in the early stage of the design process. And daylight analysis input your geometry of the building and scene, surface material properties, reflectance, its glazing, all these, particularly reflectance, light source, where the light comes, then camera or grid or of sensors, means where you want to have the daylights, means when you are simulating, you need to have some grid. It could be a 1 meter, 1 meter, 2 meter, 2 meter grid, depending on the room size. At the center of the grid, at a certain height, maybe at your desk height 0.8 meter from the floor, you need to understand how your lux level. Then computation, simulation, algorithm, real-time simulation, rapid tools, artificial intelligence, simplification, output, numerical, visual. So this gives you this much of lux, and visual, you would be getting the pattern that these are the highly high lux area, these are the glaring area, these are the low lux area. So in the result, you can have that. And it has also some iterations. So you may have to increase the glazing area. You may increase the reflectance of your flooring, of your ceiling, of the walls. You have different sky conditions also to take into consideration. Clear sky. You could have means cloudy condition at different times of the year. So as well as day. So you can have that analysis done, and that gives you the understanding how much light you would require and what would be the lighting system. Now it matrix the illuminance lux what we generally used, and generally our means usable daylight is as per the green building codes are 110 to 2000 lux. That is the usable daylight we generally doing during the simulation process. Then daylight factor. The ratio of indoor illuminance to available outdoor illuminance under overcast sky condition indicate daylight availability. And different metrics to understand different conditions and as well as your requirements. To when your requirements are different, you need to have different types of metrics. And daylight autonomy, it is a new term. The percentage of time that a building or space's daylight levels are above a specified illuminance level. In mostly it is used 300 lux because in your working days minimum lux level is 300. So that is the when we are doing daylight autonomy, particularly for office buildings, it is there it is mostly used. So there we are using this thing and 300 lux. And annual other metrics, annual sunlight exposure measures area that receives excessive direct sunlight over a year, useful for glare and overheating analysis. The spatial daylight autonomy, the percentage of an area that receives sufficient daylight, usually 300 lux, for a specific period, measuring daylight sufficiency and useful daylight illuminance. In our Energy Conservation Building Code of India, we are generally using this thing, useful daylight illuminance, for getting our mandatory daylight requirement fulfilled. So in Energy Conservation Building Code, there is a mandate to have a certain percentage of daylight for different types of building. For office building, it is 40%. For assembly building, it could be 10%. So maybe it could be exempted. In a cinema hall, you may not require any daylighting. So depending on the building, there are different percentage and different rating system. For ECBC, 40%, ECBC plus it is 50%, and the super ECBC code it is 60%. So these useful daylight illuminance UDI is metrics generally used. Now another matrix is there, that is glare matrix. The daylight glare probability is a metric that predicts the likelihood of an observer experience discomfort glare at a given orientation and view position. DGP is typically calculated using a fisheye rendering with an opening angle of 180 degree. The values for DGP ranges from 0 to 100% and are divided into 4 bands. Less than 0.34, then imperceptible. It is creating no harm. And if it is going more than 45%, then it is intolerant. Then your eye cannot tolerate, and you cannot work in that environment, in that daylight. So much daylight is there, you cannot work. So that is also a matrix. Now coming to the last for the designing of a building is tool for ventilation potential. That is, we are using CFD analysis, so that for CFD analysis you require first it is to visualize and quantify velocity and pressure profile in and around buildings. The effect of both mechanical and wind-driven natural ventilation can be accessed. It is seen as an early design decision tool, so that your orientation of the glazing, building orientation definitely, but not only building a orientation, in some cases, we are projecting some windows in such a way, just like a camera zoom, we are having some windows in some of the buildings where the to get daylight, but not the glare. So when the sun moves in that direction, so it goes up. So it is not directly coming into the room, but the natural daylight means skylight would be enough to have that above 100 lux or 300 lux. So that is also there. So CFD, it is also required to have the wind and to reduce the wind speed to some extent, to have the ventilation if the room doesn't have that orientation. So CFD is there. Effect of both mechanical and natural, useful for architect, engineers, town and city planners and consultants. And list of software, Energy Plus, what we have used for the energy simulation, used for daylight simulation, a versatile software, Energy Plus, Design Builder is one of that. So it is being used for CFD analysis. The Transys is also used for your energy consumption, energy simulation, but not for daylight, but Transys is for CFD also. So simulation and other consideration at neighborhood level, identify the target and surrounding buildings for the analysis, cover up to 3H radius, means 3 times height of your building. If that could be the radius from center of your building, the surrounding areas, and then you can have your CFD study. Without those data, means if you don't have any data of the neighborhood, you cannot have CFD study. You need to have another data, that is the windrows diagram, that throughout the year which direction the wind in that locality or particular city it generally moves. So that is also an input tool. Consider ground slope of each block, surrounding environment, predominant wind direction that I have just told with magnitude. In windrows diagram, you have the magnitude, the reference wind height of reference wind height of magnitude, optional custom wind profile. Input wind data, direction, velocity, site location, building geometry and floor plans, external, internal openings, surrounding environment. Now through the software, the output is wind velocity vector and velocity contours within your floors. Particularly maybe within your rooms. In residential buildings also we are doing that. And in residential building, the comfort level at a certain temperature as per Indian thermal comfort, adaptive thermal comfort, you have certain temperature with that wind speed. If you have that wind speed, you may not have discomfort. Means if you have proper wind at 34, 38 degrees centigrade also, you may not feel that much discomfort. So that is there within your room. If there is cross ventilation, particularly it is very much used for residential buildings to give to understand the discomfort level, as well as pressure matrix that is generally used for used by the structural designer, as well as your window glazing design. So pressure controls, wind velocity and pressure on facade, and wind volumes. CFD analysis, this is the CFD analysis. If the wind comes from a direction and goes through the set of buildings, then the wind with the shadow, wind shadow. We are generally telling the wind shadow that some buildings are so shadowed by other buildings that wind is not reaching throughout the year. So we generally trying to tell the architects, generally it is coming at the after completion of the design. We don't have much say about that, but we have the potential. And in West Bengal, we are doing microclimate studies. It is a mandate for high-rise building above 7-story to 21 meter for environment clearance by Poribesh Daptor or SIA. So we are doing a microclimate study. There we are showing that there are climate means wind shadows. Means some buildings are not getting winds in a large complex of buildings. So they are sometimes taking measures. Means sometimes some additional ventilation measures are provided there. So these are the things. So variation of wind potential from bottom ground floor to top floor, data representation using various techniques for better explanation of results, identification of strong spots for assisted mechanical ventilation, and design alteration to improve wind-driven ventilation. Now, coming directly to the, we are almost coming to the fag end, that Aranyo Bhavan Jaipur, a case example, India, that this is the a building which has been designed initially by the architect, and a plan has been sanctioned. These are the architect, this is the data, project data, number of floors, number of users, all these. Now, it is the design project timeline. You have these things. Now, just approved architectural drawing. This is the approved architectural drawing, and in the plan, the profile of the site as well as the profile of the building. You see the courtyards, the type of the outer courtyards and the service courtyards are very nicely designed. Because it is Rajasthan, so it is a composite climate zone. So courtyard helps in having a ventilation during hot summer days, as well as the daylight in the cold days. The specification is like this. Initially, original building design, it has been done in this way, that just 230 brick wall, a 150 RCC slab roof, glazing was like that. These are the parameters. I didn't cover that in this presentation. There is a called U value. It is a heat ingress, means heat flow value, means the capability of heat flow. U value 5.8 watt per meter square per degree Kelvin. Heat transmission value. Solar heat gain coefficient, it is actually very important for solar, means where the solar rays are very high. So actually, with the solar means daylight, the heat are also coming. Because that is also, heat is also a electromagnetic wave. So light is also an electromagnetic wave, and when light comes along with it, it also comes in the form of infra, but the wavelength have some potential to generate heat. So SHGC 0.8, VLT 85%, it is clear glass. Now, veranda on each floor, shading the walls and windows. Light power density 7, light power density LPD. So 7 watt per square meter. In the entire building, light power density 7 watt per square meter. EPD 10 watt per square meter. Now, HVAC, air conditioning, air cooled VRV system. Air cooled system, COP, coefficient of performance. So we generally have ER value in your room air conditioners or everywhere. You just check the label. You would be having ER value. ER value is just like COP is multiplied by 3.561 or just nearer values. So to give the ER value. So COP and UR has a direct relationship, and cooling system was 230 ton. So just point it, note it, to 320 square feet per tier. Generally, our refrigeration, cooling system, air conditioners, salesmen, they are giving us 1 ton per 100 square feet. In the initial design, since it is a very good design, aesthetically as well as its orientation wise, all these 320 square feet per tier. Now, budget was INR 300 million. So, including services. The shared goals budget should not deviate much from the approved. Initially, it has told by the government that you cannot overshoot the budget. You have to comply with CCDC. Target EPI 70, less than 70 kilowatt hour per square meter per annum. 5-star rating as per BE star rating for air conditioning office building. And Energy Star rating program, these are the Energy Star rating program. You can check from BE website. It is revised. It is just last year data. So it is just recently revised. New star rating system came into being in by BE. They are now asking all the private and government building owners to rate their buildings for this star rating system. Now, area simulated under Charette. These are the things. This block, only the west block has been simulated. Now, the initially original design, the light cooling, because it is Rajasthan. So cooling 67% of the annual energy consumption for cooling only. And equipment, there are air conditioners, sorry. Now, other than air conditioners, there are so many other equipments, the office equipments, your computers, printers, pumps, motors, lift, and some copiers, etc. So many equipments are maybe electric vehicle charging, charging system, basement ventilation chargings. So ventilation system also there, and lighting 4% only, because other energy consumption are so high, lighting comes in percentage wise lower. Now, when the design done, what it has been done, the proposed design with passive measures. Roof U value, just going back, earlier roof U value was 3.2. Just check 150 RCC wall, 3.2 watt per square meter. Per square meter, 3.2 watt was coming within the building internal area. Now, your earlier EPI was 77 kilowatt hour per square meter. Just coming to that, now roof U value from 3.3, it comes down to 0.6 watt. So it is much lower, at least 5 times lower. Wall U value from 2.5 or something, 2.05 wall U value, 233 brick wall, it comes down to 0.5 watt per square meter per Kelvin. And instead of single glazing, clear glass, it is being used double glazing with U value 1.8, from 5 point something to 1.8, SHGC from 8 point something to 0.24, VLT 85% to 36%. With that, the cooling system TR, just look at that. TR requirement from 230 TR, it comes down to, the demand comes down to 165 TR. So after design workshop, and from 77 EPI value, it comes down to 53, 31% reduction. Increase in budget 6 million, means 60 lakh. Approved budget 300 million. So increase in budget 2%. Typical cost of envelope measure 50 millimeter EPS in brick cavity wall. 700 rupees per square meter. Cost of adding 50 millimeter puff insulation on roof slab, 900 per square meter. Additional cost of high performance low SHGC glazing, 3,000 per square meter. But since we have only 20% window wall ratio, this cost has not overshoot. So savings per operational energy, INR 2 million, means 20 lakhs per year. So payback period is 3 years only. But not only that, your capital cost on, it is overall, means 6 million in consideration of that, for 160, 230 tier to 165 tier. So it goes down. So your overall budget is just around 60 lakhs. That's increased. So that's the thing. So it is the point, whatever I have told today, that integrated design with the using of some simulation tools, as well as inclusion of a commissioning agent at the very beginning of your schematic design, could save so much of energy, which has a payback period maximum. It is a small building. If it could be a hospital building, super specialty, if it could be a five-star hotel, if it could be a mall, then the payback period could be much higher, maybe 5 years. But your building life is 60 years. So, and once constructed and installed, means air conditioning system, piping, ducting, you cannot change for rest of the 60 years. So if you could include a commissioning agent and MEP consultant, energy analyst at the very beginning of the of your this stage, schematic design stage, that could be beneficial. So by this way, just by having a management system, a good management system, you could have a reduction of 30 to 50%. And that directly converted or translated into CO2 emission reduction and less global warming. And your climate change means our fight against climate change and our energy sufficiency will get a boost. So that's all. Thank you. Thank you so much for patient hearing. You can write to me in this. Call me in these numbers. So if you have any question, please ask as much as possible. It is already late. Many have their dinner times maybe crossed. Ideal dinner time 7:30 to 8:30. In Indian time, definitely we could have some relaxation of up to 9:30. So if you have any question, you can ask. I will tell you. Otherwise, can answer through your emails.
Thank you, sir, for this enlightening session. Now I request participants, if they have any query, they can ask.
Thank you, sir.
We extend our sincere thanks to Mr. Saibala Saha for his enlightening lecture on urban design in the light of national and international policies. His vast professional experience and deep insights into sustainable urban practices have truly added immense value to today's session. With this, we come to the close of session 4 and successfully conclude the second day of our faculty development program. On behalf of the organizing committee, we thank all our experts, participants, and dignitaries for their active engagement and contributions. We look forward to meeting you all again tomorrow for another day of rich discussion and learning. Thank you. Thank you, sir.
Thank you.
Now we are ending today's session. Thank you. Good night.